Okay, 7th grade, we're back for Chapter 4, Section 4, Day 2. And we're going to do something that is very remarkable. We're going to find square roots by hand. No calculator. And then we will use a calculator at the end. This is a method of finding square roots for non-perfect square numbers. And often students don't learn this while in school. So you will be the top students in your future schools because you will know how to do something that others don't know how to do. And it's not that hard. So let's take a look at finding square roots by hand. Okay, you don't need to write this. Look at this though and watch this. See if you can understand. If I'm taking the square root of a perfect square number, like 49. Let's take the square root of 49. We know the answer to this, right? We know that the square root of 49 is plus or minus, let's take the positive root. So it is 7, right? So let's think about it this way. If we were to take 49 and divide it by 7, 7 times what equals 49? And I'm sure you know that 7 times 7 equals 49. And look at that, there's no remainder. There's no remainder. This is a perfect square number. So notice that the divisor and the quotient are a perfect match. And that's true when we find the square root of a perfect square number. The divisor and the quotient are the same, right? 7 times 7 is 49. Well, we're going to use this idea that the divisor and the quotient are the same when finding a square root. Okay? So let's go back to the square root of 23. The square root of 23, wow, that's not a perfect square. So we're going to use a method that some of my previous students helped me name FEDAD. You will learn FEDAD. And FEDAD begins with the F. We need to find the closest integer that square root of 23 is closest to, okay? So just like we did yesterday, we can say that the square root of 23 is between what two perfect square numbers? Yep, it is between 25 and 16, right? So we want to think about which of these two numbers 23 is closer to, right? 23 is only 2 away from this one, right? From 25, and 23 is 7 away from 16. So 23 is closer to 25, right? So the next step is E, estimate the square root. So the square root of 16 is 4, and the square root of 25 is 5. So the square root of 23, the number we're after, is 4 point something, right? And so let's make an estimate to the 10th place, okay? So what number should we put in the 10th place as we're estimating the square root of 23? Again, if 23 was exactly halfway between these two numbers, 16 and 25, then we would estimate our square root to be 4.5, which is halfway between 4 and 5, right? But 23 is closer to 25. So we are going to estimate a number that is closer to 5. Not 4.5, but maybe 4.6, 4.7, 4.8, 4.9. What would your estimate be? How close is 23 to 25? And I bet you're thinking something like 4.8 or 4.9. So let's try 4.8 as our estimate. 4.8. Okay? We now will use the D. We will divide. Okay? We're going to take the original number 23 and divide it by our estimate, which is 4.8. And when we do, we're looking for a match between the quotient and the divisor. So we're dividing by a decimal, so let's move the decimal over once, right? That decimal up in our number. And now 48 goes into 230, probably 4. Let's see what 48 times 4 is. 8 times 4 is 32. 4 times 4 is 16, plus 3 is 19, 192. So let's subtract 192. And when we do, 38, a remainder of 38. So let's bring down the next place value, bring down the next zero, right? And do you think that 48 can go into 388 times? If it did, we would have a match, right? 4.8 and 4.8. Let's go see what 48 times 8 is. 48 times 8. 64. Carry the 6. 32 plus 6 is 38. 384. A little too much, so we'll have to say 4.7, right? And 48 times 7, let me scratch paper here. 48 times 7, 56, 5, 28 plus 5 is 336. So 336, and we have a remainder, don't we? 4, this becomes a 7, or we have a remainder of 44. So imagine if we went and brought down the next place value. Well, 48 times 8 is 384. So 48 times 9, we know that we could actually put a 9 here. 48 could go into that number 9 times. And guess what? That means that this number here rounds to, if we look at the neighbor, the 7 in the tens place rounds to 8, right? So as we look at our divisor and our quotient, we have a match. Yay! Our estimate was the perfect estimate to the tenths place, okay? If we didn't have a match of 4.8, we would take these two numbers, the divisor and the quotient, and we would average them and try to then use that average to make our next division, and we would have a match at that point. You know what, let's try another one, because I know this is confusing the first time you see it. After seeing it a few times, it'll feel a lot nicer. So let's try another one. Let's take the square root of 41 to the tenths place, okay? And let's start with the F. So F, find the two perfect square numbers that these 41 is between, right? So 41 is close to 49, right? And that's 7 times 7. So 6 times 6 is 36. So it's between 36 and 49. So let's make our estimate to the tenths place. Well, the square root of 36 is 6. So our estimate's going to be 6 point something, right? The square root of 49 is 7. So 6 point something. Now, 41 is 7 away from 49. Oh, 7. It's 8, actually. 8 away, right? 8 away from 49. And 41 is only 5 away from 36. So 41 is closer to 36 this time. If 41 was halfway between 36 and 49, we would estimate 6.5. That would be halfway between 6 and 7, right? But this number is a little closer to 36. So we're going to estimate something a little less than 6.5. So how about if we estimate 6.4? Okay, 6.4. So now let's go ahead and divide and see if we have a match. Okay, I'm going to move that over a little bit. 41 divided by our estimate, 6.4. Once again, you move your decimal once over, right? And 64 times 6. If we made a good estimate, we're hoping that the quotient is 6.4, right? So let's multiply this. 6 times 4 is 24. 36 plus 2 is 384. 384. And we're going to have to borrow and subtract, right? And we're going to borrow again. 10 minus 8 is 2. So there we have now 26 remainder. So let's bring down a 0. Right, bring down a 0. And does 64 go into 260 4 times? If it did, we'd have a perfect match, right? So let's go see what 64 times 4 is. 4 times 4 is 16. And then 6 times 4 plus 1. Ooh, 256. Yay! 256. Now remember, we're always going to have remainders because these numbers, square roots of not perfect squares are always going to leave us with an imperfect situation here, right? But as we look at this, we don't have to go further with our division. Look at this. We have a match to the 10th place. So after having divided, we know that our estimate, the square root of 41, is approximately 6.4 to the 10th place. Yay, we didn't even have to average. Let's try this again. This time, let's make a bad estimate so that you can see the entire FEDAD, okay? That's kind of funny. Square root of 24, we know, is between, find the two perfect squares, between 25 and 16. Square root of 16 is 4, and the square root of 25 is 5. Okay, so let's imagine that a student makes a bad estimate here. So the square root of 24 must be 4 point something, a number between 4 and 5. 24 is so close to 25 that I think most students will estimate that the square root of 24 is 4.9. But let's imagine that a student estimates it to be 4.4 or something small, okay, something really small. So this student will have to divide, just like all students have to do, right? So we take 24 and divide it by 4.4. Now, don't forget, we got to move our decimal, right? And let's see, 44 can go into 240. Let's imagine, let's see if it goes in 4 times. Okay, 6 ones, 176. Wow, could it go in again? 44 times 5. Let's see, 0, 2, 220. Wow, it can go in 5 times. So I've got 5 there. 220. We subtract, and let's bring down a 0, right? And 44, how many times can it go into 200? Well, probably 4 times, right? We already did that. That's 176. So there's 5.4. Subtract. Again, we've got to borrow. This becomes a 9, right? So 24. And we could keep going, but we're just trying to get a match to the 10th place, right? And I have 4.4, and I have 5.4. Well, those are way off. So the next step in FEDAD is to average. If you need to, if you have a divisor and a quotient that do not match to the 10th place, then we're going to average. And we're going to say, how do you find the average of 2 numbers? That's right, you add them and you divide by 2. And what does this equal? Well, we have 9.8 divided by 2. And how many times does 2 go into 9.8? Well, it looks like it goes in, wow, 4.9 times. So our new estimate is 4.9. And what we'll do now is divide using 4.9. Okay, so again, 24 is what we were finding the square root of, divided by 4.9. And we're going to move our decimal, put it up in our answer. 49 times 4, 36, 16 plus 3, 196. Okay, we subtract. 10 minus 6 is 4, 13 minus 9 is 4, and we bring down a 0. And 49, can it go into 449 times? Let's see, 81. 4 times 9 is 36 plus 8. 36 plus 8 is 441. Wow, it's a little too much, just a hair too much. So the number will be 4.8. And then guess what? The next number will be, let's go see, 49 times 8, 72. 36 plus 7 is 41. 412. The next number is going to be really big, isn't it? 3 minus 1 is 2. And we have 280. So 49 can go into 280. 1, 2, 3, 4, 5. At least 5 times, I think. 49 times 5, 45, 24, 245. Yep. So at least 5 times. So if we now round this quotient to the 10th place, does the 8 stay the same or increase by 1? You're right, it increases by 1. And we end up with 4.9 here and 4.9 here. Yay, it's a match. We have found the square root of 24 using the entire FEDAD. Okay, if you are going to use a calculator to find square root, then you could follow these steps. I'm going to show the steps for our TI 30x2s calculators. So if you have negative square root of 72.25, you could input that like this. You would press the negative button on the lower part of the number pad, and then you would press second function, and you would press the x squared button. When you press second function, you don't get x squared, you get what's behind it on the back of the calculator, which is the radical sign. So you get second function, you get the radical sign, and this is what shows up in the screen. And then we're going to put the number in, 72.25. You type all these in, and that's what you see in your screen. You then type a closing parentheses, if you like, and press enter. And when you do, you will get the negative square root of 72.25, which is negative 8.5. Okay, so make sure that your screen looks like this as you're entering these pieces of the expression, and you can take the square root of a number using your calculator as long as you know how to use the second function and the radical sign. Okay, good job. And here's your assignment. You may use your calculator for these, but for number 30, please do it entirely with FEDAD.